Hi guys, we're on our last three variable, three equation system. This one is going to take the most work on your part, but it's not something you can't handle. It's just taking stuff that we've been doing and doing it over and over and over again until you get your answer. So don't worry about it's not like a super difficult problem, but it's going to get a little bit intense with the amount of work that you have to do. So let's get started. So here's my initial system. And as you can see, I have my three variables and my three equations. And this system has been set up for elimination. And I can tell that because everything is stacked nicely on top of each other. I've got my x's, my y's, my z's, my equal signs, and my constants. And so since everything is stacked up all nicely, that means I should use elimination. Unfortunately, unlike yesterday, I don't have a letter already eliminated from one of my equations. All of my equations have all three variables. And so the first thing that I'm going to do, well, I'm going to put a box around those so that I don't forget these are my original problems. But I'm going to make an executive decision, and this can be any decision you want to. It does not matter, but I'm going to make an executive choice about which letter I want to eliminate and which two equations I'm going to use to eliminate that letter. So you have to pick X, Y, or Z. Doesn't matter. You pick anything you want. And then you're just going to use two equations at a time, and you're going to eliminate that variable that you chose. So I'm choosing to eliminate the variable X. I made that choice because of the middle equation, which has a letter X with no coefficient. So I knew that it wouldn't be too difficult to eliminate my letter X. Now I'm going to choose two equations that I'm going to combine together using elimination to eliminate the letter X. And it doesn't matter which two equations they are. Again, I already told you I like that middle equation because there's nothing in front of the X. And so I'm going to choose the first and second one. This was a personal choice. It's not mandatory that this is the first thing you do, but this was what I chose. And if I'm choosing the first and second equations, then I'm going to eliminate by multiplying the second equation by a -2. Then I'll have a positive 2x and a -2x. This time you have to multiply 4 places by -2. You've got to multiply the x, the y, the z, and the constant. So again, if you are making a mistake on these problems, my guess, the first thing that I would check for is, did you actually multiply everything by the same number? And so here's my top equation and then my new second equation. My x's will cancel, that was kind of the point. And then I'm going to add everything else together. 1 plus 4 is 5, 3 minus 2 is 1, and 9 minus 16 is -7. So what I've created now is I've created a single equation with two letters. If I have two letters in an equation, I need to have another equation that also has those same two letters. So I've created an equation with a y and a z. I need a second equation that also contains a y and a z. So I'm going to eliminate for a second time my letter x. When I eliminate for a second time, I need to pick two new equations. So I've already done the first and second. This time I'm going to do the second and third. Your other option, you also could have done the first and third because those two have not been done together yet. So that's, again, something that you just choose on your own. Because I'm choosing the second and third, I will be multiplying the middle equation by 4 because I have to eliminate the variable x again. It's mandatory. Once I've eliminated the x in the beginning, my second elimination also has to be the letter x. The goal being to create a second equation with a y and a z. Okay, so here my x's will eliminate, and then we add straight down. So I'll get a -5y, a positive 6z, and equals 28. Just to recap, I have eliminated my letter x twice. I now have two brand new equations, and those two equations both have a y and a z within them. So what I'm going to do next, I'm going to take my two brand new equations, which only have two letters, and I'm going to do elimination for the third time. This time, I'm not going to eliminate an x because my two equations don't have an x. I'm going to eliminate a y or a z, whichever I choose. In this problem, I got really lucky. My y's are already going to eliminate. I've got a 5y here and a negative 5y here. So I can just, stack them straight on top of each other right now, and they're going to eliminate. I don't have to do anything. That doesn't always happen. Sometimes you will need to multiply one of the equations to get something to eliminate. But we just got kind of lucky in this problem. So here my y's are going to eliminate. I'm going to add straight down, and I'm ready for my first answer. So just to recap one last time, I did elimination 3 times. The first 2 times I had to eliminate the same letter, and then the third time I picked a different letter to eliminate, and I'm at my first answer. So triple elimination before you get to your first answer. Now that I have my first answer, I can start very little bit easier. I can find the rest of my answers. Now I'm going to change the slide because I'm kind of running out of room here. These were my original problems, and these were the new equations that I created. So now I have my first answer, which is z equals 3. I'm ready to find my second answer. To find my second answer, I must plug 3 into an equation that only has 2 letters in it. One of them should be the letter z, and then only one other letter. So I'm going to plug it into one of these new equations that I created. I'm not quite ready for the original equations yet. I need to get my second answer before I can move on to those equations. So I'm going to plug it into the top one because it has less numbers in it. So I figured that one's probably going to be easier. So I've plugged in my 3 to my z. And again, we're plugging it into this equation because now I have only a letter y in this problem. And so I can very easily solve for y. And now I have my second answer. Only after you've gotten 2 answers should you go back to the original equations, and that's where you'll get your third answer. So now that I know z and y, now I'm ready to use an equation that has an x and a y and a z in it. And I will be plugging in my y and my z, and I will be solving for x. Now you can use any of these 3 equations over here. I chose the middle one because the x and the z both don't have coefficients, so I thought that might make my life a little easier. So I'm plugging in my y and my z, which leaves me with only a letter x, which is the last variable that I need to solve for. Don't forget your final answer must be in a very specific order, x, y, and z. My final answer is 1, -2, 3. If you're ever unsure of your answer, you don't think it's right, you're just kind of questioning yourself, you can take these 3 numbers and plug them in. You do want to check it in all 3 equations. They have to work in all of the equations. If there's any equation it doesn't work in, then you did make a mistake and you'll want to go back and check your work. This concludes our 3 variable, 3 equation systems.